Thank you.
No problem.
All right, I think I'm ready to go.
All right, welcome back with our second session of today's conference. Now I would like to move on to our next session with our keynote speaker, Kyle. And the topic today is continuous integration. Taylor, would you like to introduce a little bit?
It's sort of the merging and sharing of work of coders. So let's welcome back our first keynote speaker, Kyle van Winkoop, on his speech about continuous integration. A Q&A session will follow after the speaker, so make sure to send all your questions to the link that we will be posting in the chat, and they'll be answered after the speech. After such an exciting workshop from him, we can't wait to see the next presentation he has to share. Let us give him a virtual round of applause and get ready for this next session.
All right, awesome. I'll just share my screen here. There we go. All right, then let me get started with the talk on continuous integration. So I'll be largely talking about here continuous integration in game development. So from like a kind of game development standpoint, but the stuff I'll be talking about should apply to all software in general. So your first question probably is, what is continuous integration? Perhaps you've heard of it. It is starting to get very popular, but perhaps you never kind of heard of it, and this is the first time. So to kind of explain continuous integration, I'm going to show a bit about regular workflows when you're coding. So let's say you're either making a game or you're coding some big project, something like that. There's a bunch of different ways you can go about it. Let's say you're working alone, you might kind of do this monolithic workflow where you start, you have a little bit of code, you add more to it, you add more to it, you add more until you got a bunch of code, and then the project's done, right? So pretty simple. Whenever you're working on an essay alone, that's usually how it goes. You just add to it, and then it gets bigger, and then that's it. Well, let's say instead now that you're working on a group project, you might do something like a split workflow. So you'll split it up into a bunch of different tasks, and right at the end, you will combine it all. So if you've coded in big groups before, and you've had large projects that everyone's had to contribute to, you're probably kind of familiar with split workflow. If you're using a platform like Git or SVN, you'd kind of work on a feature, you'd keep on coding it, and then it would eventually be done, and then you'd merge it back into the main, right? And everyone would merge their work in, and you'll have this big thing at the end that's kind of finished. Okay, so continuous integration is actually an alternative to that, where you continuously work on something, add it to the main, take it out, work on something, add it to the main, and then keep on going. So what this will basically look like would be that you have one main chord source, one main set of everything that you have, and everyone would work on small tasks, not always whole features, but very small pieces. They would complete that small piece and they would merge it back into the main, right? Then they would work on their next task. They would take away again, they'd work on their piece and they'd merge it back. And everyone would be doing this continuously. So as soon as you're finished, they'll merge back and then they'll take out a new one, merge back, take out a new one, and so on. This is different from the split workflow because the key is how often we kind of do it, right? So I notice here, if you've ever done some group projects, sometimes you'll split stuff up. You work on the presentation, I'll work on the poster. Really, you don't put the presentation and the poster together until the very end when you show them off to your teacher sometimes, right? In continuous integration, you won't even be finished like a small part of it, and you'll still merge it back into the main code. There's a lot of reasons for why we do this that I'll kind of get on into the main thing and how it can be useful and why you might want to consider using it. But let me just to give a bit more of an overview of it. It's based around many small modular tasks. So let's say you're coding something like you're adding a new feature to the game. Perhaps you're adding a ranged weapon. You're adding like a bow and arrow, right? Well, you try and break that down into the smallest tasks you possibly can. So one task might be create a class for the arrow, right? Then another one might be create the bow inventory item. Then another one might be add the shooting to the bow inventory item. Then you might even break it down even more and say, well, add the arrow hitting an enemy, right? And all those would be separate tasks that you'd make, that you complete and merge back into the main separately. So for this, you make a lot of branches, all branches based on small tasks. Like I mentioned, you merge very often. So sometimes when you're working on a coding project, you won't merge for like a week or even a month. But for continuous integration, you want to merge every single day, at least once every day. That would be if you were working on like a project full time. If it's something you're working on part time, maybe it's not every day, but almost every single time you work on it, before you leave and you go do something else, you merge. That's kind of one of the ideas of continuous integration. So when you're merging stuff, you'll often run into errors, right? Maybe you and your teammate both merged together at the same time, and you both were working on the same file. Well, then you'll have to kind of deal with that and figure out all that. The idea is that you want to deal with that immediately. As soon as you merge, you fix it so that what's on the main branch is always working, right? And before you move on to the next thing, you have to kind of fix that build error. Then you branch off and into one main branch again. If you're familiar with GitHub, you might see that some people, they'll make a branch for a certain feature, and then they'll branch off that branch and go back into it. Well, for continuous integration, you mostly just want to have one main one that we're going back into and out of, and back into and out of. Lots of small ones, but the one that's actually working, yeah, just one of those. So what does it look like? It looks something kind of like this. So this is from one of the projects I'm working on called Sidetrack. It's this is an example of what continuous integration might kind of look like. So all of these kind of blue bars going to the side are branches, right? So here we have /main. This is our main kind of code base. And the arrows are kind of reversed. When you see an arrow going to it, it's really means that I branched this main /scm22 came from main, right? So for example, it created this branch, and then way over here, it was merged back in, right? This day, someone created a branch, merged it back in. Created a branch, hasn't merged it quite yet, and they'll have to merge it soon. And here, someone, this branch wasn't exactly created, it was a bit different, but merged back in. So as you can see, some of these have, I should probably mention what all these circles are. These are all changes in the code. So for example, for this one, they created a branch, made one change in code, merged it back in. Sorry, for SCM65. Then for this one, it was kind of the same thing. For this branch on the bottom, maybe it was a bit of a bigger thing. They branched off to SCM22, and then they made 1, 2, 3, 4 changes, and they went back. So for this project, we're working on it over a couple of months, and so it takes quite a lot of time. And so we don't exactly merge back every single day like we should be. For a lot of professionals who kind of work on projects every single day, you'll notice that in the same day they'll branch off and merge back maybe multiple times even. But this is in general what it looks like. This window is taken from a program called Plastic SCM. If I have more time at the end, I'll show you what it looks like. and I'll probably give you like a little tutorial of it. But it's a program specifically made to help with continuous integration. It's an alternative to GitHub or SVN, those kind of things. So what are the biggest differences? When you're doing continuous integration, there is a redundant amount of small tasks. So way too many small tasks. Like I said, you'll separate, like when you're adding a bow weapon or ranged weapon like a bow, you'll separate adding the arrow into adding the bow, and adding the bow firing and adding the arrow hitting into multiple different tasks when normally you just kind of just do it all at once. Yeah, merging code back in daily, I mentioned, big difference task. So normally when when a lot of projects do stuff on GitHub, they'll branch off and they'll make another branch based on a feature. So the feature will be ranged weapon, or the feature will be text chat or something like that. And it's a feature that you'll add. For this one, rather than making feature-based branches, you do task-based branches. So every little kind of code that you add will be a branch rather than the whole feature. One thing is, so constant build testing. So one of the big parts of continuous integration is that it rebuilds the project every single time you merge back in. So for example, normally when you're coding, you'll kind of make a big program, right? And then once you're done with everything, you'll try and build it and create an executable that people can actually use, right? You'll compile everything and it'll go. Well, with continuous integration, as soon as you merge the small task, you'll test to make sure it can compile and actually build, right? And then you'll branch off again, then you'll come back and then you'll test to make sure it can actually build. So that throughout this whole process, you have like a little demo almost. You have a working base with a bunch of code. And then you always push something and then by the end you just have something that's good enough to that has enough features that that's fully done. But that's one of the big differences, is that you constantly have those builds rather than just doing it at the end. So why kind of would you use it? Well, here's a lot of advantages that it really brings. One of them is easier collaboration. When you're working with others on code and you change a ton of files and you're trying to merge it with someone else who changed a ton of files, it can be a nightmare. When there's so many changes to look over and you're trying to figure out which ones are going to break, which sides to take, it can take so much time up, and it can absolutely halt your progress right at the end, right? Well, it's easier to track progress and see how far along a feature is, right? Because you can see how many tasks are done, etc. And that also goes back to the productivity tool, which I'll talk about a bit later. Yeah, this is actually pretty useful. So it's easier to see where breaks and bugs occur, right? As soon as you merge it and you have the build, you can kind of see if the build fails and if there's some crazy bug that's broken. You can also look back and see when a feature was added and how long a bug has been there based on the history. As you kind of saw back up here, all of these are dated, timestamped. It shows you when it happened, exactly who did it, when it was merged back. And so it's really easy to track where problems happened. Makes code review simpler and easier. So in a lot of teams, you'll have the code will be complete and someone else will come and look over it and see if you made any mistakes, or try and make suggestions on how it can be improved and that sort of thing. Like a code reviewer will usually be in charge of that. Well, breaking it into small tasks makes it much easier to review and see what's going on than if you get a huge boatload of code and you don't really know where to start, right? Makes a lot of room for automation. So one of the things about the build that I mentioned is that sometimes the build can actually take a while, right? And if you've ever built anything, like actually made the executable, you'll know that if you're using Visual Studio, it can be a bit of a hassle. You got to go up and hit build and select the compiler, etc., all that. But one of the things about continuous integration is that you can set it up so that as soon as you merge, it'll automatically, on the cloud or on some server that you have set up, build the project for you. So you can just start on the next task while it's building and making sure that everything's okay. Yep. It can also run automatic tests on your code. If you have an automatic testing suite, you can get it so that as soon as you merge, it'll automatically run all those tests on your code, which right now is a very popular thing in the industry, automation. Yep, like I mentioned, always provides you with a working build. So if someone wants to see what the product currently looks like, you can always show them, even if it's not fully complete yet. And it's easy to use with a productivity tool. So I mentioned this a bit earlier. There are tools like Jira or Trello where it lets you break these bigger tasks into smaller tasks and keep on going. And this tool works quite wonderfully with that because it lets you track them. Before you mentioned all these SCM 65, SCM 22, those are all ticket numbers on our Jira. If I have more time at the end, I can actually show you what that looks like and kind of, how that relates. But yeah, so those are mostly the advantages. It's not all sunshine and rainbows, so it comes with some disadvantages. One is that that's a lot of branching and merging you got to do. And a redundant amount, like I mentioned, is that like you're branching way too often. For all the advantages it comes with, it does take up a bit of time, especially when the time-consuming merging issues, you have to deal with them right away. Sometimes if you merge everything right at the end and you deal with all those issues at the end, it feels like it can be more efficient than having to deal with them every single time you do it. Yeah, dealing with them right away might save you a lot of headaches later, though. But anyway, one thing is that strict deadlines encourage complete code. I mentioned that you're supposed to merge in very often. Well, if you're working in a group and you have a deadline for a certain task, not a whole feature, but just a part of it, and that one part of the task ends up taking quite a while. Well, if you're expected to merge very often, you might be tempted to kind of put code in there that's not really fully done, not really well tested, might end up breaking. And you might be tempted to put it in there just to meet the deadline of a remerge by the end of the day. And that can be kind of dangerous. So that's hopefully this system encourages that a little bit, which is quite unfortunate. Sometimes tasks are difficult to split up. Sometimes you'll have to add a big feature like a text chat, and it'll be hard to split it up into things that you can complete in like one day, right? And like very short things like that. So because of that, sometimes you have to be a bit creative about how you split, and it doesn't really turn off too well. Hard to set up. So if you want to use SCM, like I mentioned, we use this plastic SCM, this system, which works quite well, and it's automatically all set up. But if you wanted to use a different system, it'd be quite difficult to set up. And even plastic SCM itself, you have to have a server to hold on to all the code. If you're not using one of the servers that Plastic, the company that owns it, has set up, and you want to set up your own, that can be quite difficult. These servers need to work quite hard to store all this code, and the SCM system, although it is quite efficient, it might not be as efficient as SVN instead of SCM. Sorry, it might not be as efficient as GitHub or SVN, but anyway, it's also harder to slack off. Unfortunately, if you your whole team, as you can see exactly what's going on. So I can see well, I mean, in this page, I can't. If I could click, I can see, oh, my buddy Lucas created this branch. Now he's merging it back. Well, you can kind of see who didn't work on the 30th, and you can see that we kind of took the 31st off or something like that. And it makes it kind of harder to slack off, which isn't always particularly a bad thing. But yeah, I mean, that is technically a disadvantage of it from the hard working programmer's perspective. But that's pretty much it. So I'll kind of go over what the typical workflow, how it kind of looks to work on a project when you're using Plastic SVN. So here's the continuous integration, and here's the split workflow. Just for like a little bit of a reminder, the split workflow is the thing you do with Git, where right at the end you kind of merge it all, and continuous integration is kind of where you. I just talked about it, so you know what that is. But right when you start the project, you would create tasks, create subtasks, and sub-subtasks, and keep on going until you've got a ton and tons and tons and tons of small things to do. For the split workflow, you would create an outline and delegate features. So you'd say, okay, here's our outline, here's what we need to be done. Lucas, you work on this, Kyle, you work on this feature, and you split them up, and then that's it. You start working on those features separately, and you merge at the end. So the daily grind will look like you pick a task, complete it, merge it, pick another task, complete it, merge it. That's kind of what continuous integration is. The development itself looks like picking a task, doing just that task, merging it. For a split workflow, it usually means adding way more code to a larger change list, like as it kind of goes. So, excuse me. So as you know, a change list is a big list of all the changes that you've done with all the code. They're quite small in continuous integration. Sometimes they're just a couple of lines, sometimes they're just a couple of files. But in Git, or at least when you're doing the regular split workflow, you usually have one really large commit, or not commit, but one really large set of changes that you're going to try and merge at once. And you'll try to add more changes and add more changes to try and get your feature done. At the very end for continuous integration, you're kind of just reviewing and reevaluating the code and seeing if there's more tasks to complete at the end of the project. At the end of split workflow, it's a big merge fest, big fix bugs, everything's in, scramble to try and get a build done and fix it all. So that's usually kind of it. So as you can see, continuous integration has quite a few advantages when it comes to the last stretch particularly, is that at the end, you already know exactly where the project is and you know how much time you'll need. At the end of split workflow, you could combine everything and find that there's these terrible gaping bugs that you absolutely can't push the project with. Like it's got too many, it's impossible. So the continuous integration gives you a better idea of what things are looking for. So now here's the real question. Should I use, oops, sorry, I'm messing with the Zoom chat window. I don't know if you can see it. There we go. So should we use continuous integration, or should you more specifically use it? Well, it's really good for large scale projects with big teams. And you can use continuous integration with GitHub and just merge often. Like the only reason why you would have to use a program like I'm using would be because it looks a lot better for continuous integration, and it's more efficient to have a ton of branches using plastic or something. But you can still use Git and just remerge back often. So that's not really too much of an issue. But it's really good for large scale projects and big teams. If you're working in a really big team on a really big long project, I definitely recommend trying to use some kind of continuous integration if you can. As often as you can, try and merge back and make sure everything's still working, and that you have something working or something to show off at least, maybe not every day, but as often as you can. It's really good for tech savvy teams who are interested in automation. Like I mentioned, the automation can be a really big part that helps a ton. And it's also good for teams that want to make consistent progress. If you're working on a project once a month or something like that, maybe continuous integration might not be too important. But if you're on a team like you're in the workforce and you're going into work every single day and working on a task every single day, it's really good for consistent progress because you can kind of see everything that's going on. It's also really good for managers. It's easy for managers to see the progress that programmers are making, and it's easy for them to see what tasks are being done, how long tasks are taking, or who took on how many tasks, and also who's responsible for bad code. You can kind of see where it was pushed and where it came from, and so that does make it quite good for management perspective. Really bad for smaller, simpler projects and for quick result kind of production. If you're just trying to make like a little prototype, you're just trying to make something quick, like for a project, like if it's a school project, and send it out there, send something to your teachers. Continuous integration probably isn't too important, right? Especially if you're working alone, then continuous integration, you might say, might not even have a point, because what you're always working on is the main branch, right? So for a lot of small, simpler projects and working in small scale stuff, it's probably not very good. I think someone asked in the Q&A, what kind of workflow is more common nowadays? Well, nowadays, everyone has been using split workflow for years, right? This was the original. Back when GitHub was super popular, all of the every company was using, well, not every company, but companies were using GitHub, or they were using something called SVN, which is it's just like Git, except it's a bit different. It's old, but you can set up your own server easily, all that kind of stuff. But they both use this split workflow. Sometimes split workflow doesn't look like merging it all at the end, and instead you merge some in the middle, right? So companies would do that quite a bit too, and make multiple builds throughout. But the whole point of continuous integration is that it's taking that to an extreme level, extremely large number of branches, rather than just 5 or 10. The people who made plastic made it using the continuous integration approach. And by the end, they had tens of thousands of branches. They had so many branches that it was an obscene amount. Yeah, you'd never do that in SVN or Git. You would never have that many. But Yep. So, well, I guess now we come on to questions. So if you have any questions about, continuous integration, anything I said, how it works, yeah, you can either send them to the Q&A now, or I think they mentioned that there might be a Q&A link that that'll have some questions. But yeah, feel free to send those. Until I get some questions, I'll talk a bit more about why continuous integration is so popular in video games, because I just realized I didn't mention very much about video games here. But one of the reasons why is because so a lot of times you have ideas for features in games that end up not making it. So for example, you'll want to add more weapons, more abilities, more tools, more this, but you'll only get a chance to add a few. With continuous integration, you can add just a couple and then continue and move on to other tasks without too much fuss. There's no real problem with it. But with Git, you kind of want to know how much that's done or how much you want, and try to put it in kind of before the end, and it gets a bit tough. So because of this, it's good to stick with continuous integration, because you can, you always have a working build at the end that you can kind of show off. Another reason why it's popular is because games nowadays are some of the most complex software that you'll find out there. Like, of course, there's software that's way more complicated than games. But if you think about it, Zoom is quite simple compared to, like a big complex multiplayer game or single player game like The Witcher. And that's why the Zoom is only like 1 gigabyte on your laptop, but a big AAA game like The Witcher is 16 gigabytes or even 30. Actually, it's way more than that now. But look, Zoom is just, you send data through screen share, through video, through audio, and the data reaches the other ends. It goes up to the server, and the server sends it to everyone. So that's pretty simple. But in a game, you've got mechanics, you've got graphics, you've got, okay, when this fireball explodes, the fire has to spread here. And then if the player walks into this fire spreads into where the player goes, then it has to take this much damage, and this much damage has to apply here. And then they're on fire and taking more damage. And then and it can get so complex. And for big complex systems, continuous integration can't be beat, I think. So that's why, because games now have, there was a time when regular software was more complex than games, back when people were making Pong and super simple stuff. But nowadays, games are way more complex than your average software. Yeah, so that's kind of one of the main reasons why it's popular. It also is getting really popular because, well, what was I going to say? Oh yeah, a long time ago, games would kind of work without, or game developers would kind of work without a manager, right? When they're making a game, the game designer would be the manager, and they would design, they would make a bunch of aspects of the game, and they go to the coders and tell them do this, and then they go to a bunch of the 3D modelers and tell them model this and so on. Nowadays, you'll have a project manager who's separate from the game designer, who's just in charge of making sure that the project is complete. Or especially in AAA games, the people who are managing the developers and designers don't really have too much to do with games themselves. They just only have to do with making a business that gets stuff done. Because of that, management has, unfortunately, in my opinion, became a gigantic. Oh, hold on, let me go to, where did I write this down? No, I guess this was good for. Managers have become a gigantic part of game development, and management has become a huge, huge part. And so that the system works well for them, and so it is kind of included. Someone asked, what are the steps to set up continuous integration? So maybe I can kind of show you. Well, so first, you can do continuous integration with, how do I exit? There we go. Oh, I realized I am nearing, or I think this was originally supposed to be 30 minutes, but I don't think there's another event after this one, so I'll keep on going until people run out of questions. So you can do continuous integration with GitHub. So if you know how to set up a GitHub project, you go to github.com and you create your repository. So you would kind of have your repository done, and then maybe you have GitHub Desktop, or you're just doing it with Git. Basically, the continuous integration way of doing stuff would be, so here's, oops, well, Here is my my GitHub desktop. I don't know if you're familiar with this, but this is kind of where you can do this stuff. So I'd have this game called I'll go to my Dragon card game. So basically what you do is you'd wake up, you decide that you wanted to work on this project. You would create a new branch right away. So I'll create this. I'm going to call it you know what, I'm just going to call it test branch for now, and I'll delete this later before my team members see that I've done this. You'll create this branch, okay, and then you'll go to your Unity program or whatever. You'll change all the code in the project, but you'll just try to change just a little bit, and then you'll publish the branch, and then you'll merge it back in. So if you know how to merge, afterwards, I'll merge this test branch back in right away, like that same day. And then I'll do that very, very often. On GitHub, the downside to that is that you'll see tons and tons and tons of branches. Like here, we only have a couple because this was done using split workflow. So there's only like 10. And GitHub isn't really made too well to handle millions of branches. So you might have to delete them kind of as you go on. But that would be continuous integration with GitHub. Now, let's say you wanted to do it full on, you want to use something better than GitHub. You have a big complex project that GitHub isn't good for. And what you might do is download, or well, you'd have to pay for it, but download something called Plastic SCM. So this is another program, and SCM is different from GitHub, or from Git, which is what GitHub is based on. So now what you do is you have your main branch up here. And let's say I want to work on something. Actually, I already have branched off. I'd go here, I'd right click, I'd create a branch. It would create this branch, and then I'd move to it. And then I'd right click and I'd merge it back in once I finish my code. And the upside to SCM is that you could zoom out and have so many branches. Right now, there's only a couple branches because we're pretty lazy right now. But sometimes you can have like huge amounts of branches. If you go to their Plastic SCM manual, they have so many of them that it's insane. But setting this up should be pretty simple if you're okay with shelling out a few bucks for the Plastic SCM. Although I'd only recommend this if you're working on a really big, serious project. Otherwise, GitHub will work fine. And this probably isn't worth the cost buying Plastic SCM. Once you do this, so Plastic will handle all the server stuff for you. For Git, it's the same thing. GitHub, the website, handles all that server stuff. If you wanted to make your own server to hold on to all the files and track all the versions, then you'd want to use something like SCM, which is, you could also do this continuous integration with that, but it's a bit tougher. And setting up that is quite difficult though. So if you want to do that, I'd recommend you look into it or look it up and see all that. So the next thing I kind of want to show, I mentioned Jira and Trello. So you might be familiar with Trello. Jira is a more advanced version of it. So basically, this is the board. It's a website that we use to create all the tasks that we're going to work on. So as you can see here, hey, there's me, Kyle Van Winkoop. There's a lot of tasks, so even 102 of them, right? And they keep on being worked on, and people will work on this one, SID 97, right? And then they'll take it on here, and then they'll come over here to Plastic SCM, and they'll create a new branch, and they'll call it SCM 97, because it's the one where they're adding that. And then they'll add it, and then they'll merge it back in. So so Jira is pretty useful for that because it lets you track all of them. It also lets you set, so we have all these big SIDs, but if I go to the board, you might notice that they're part of, or there are tasks and there are subtasks. So here I have a bunch of subtasks that are kind of, so this one is SID 66, and within it there's 67, 68, 69, 70. So 66 was the main thing that I was supposed to work on. I was adding the 3D modeling, but I was able to split it up into a bunch of small tasks, all the individual things I had to model. And I could have split this up even more, but because it was modeling and not coding, I didn't. One of the things that Plastic does well is that when you create a new branch, if I say create branch and let's change that, I can choose the tasks that I have to work on, right? So I can just like go, okay, here, I'll create a branch based on SCM 66, and it'll automatically mark it as open in Jira. And in Jira, it'll say, okay, he's working on it. There's a branch for it, and it'll fill in all that info for me. But yeah, I hope that answered your question of how continuous integration can be set up. Any other questions? Any other questions? I think this was supposed to be 30 minutes, so we are a little over, but that's okay. I think the next workshop I'm hosting starts in at 11 or my 11, which is probably a different time for you guys. But yeah, so I'll wait around for any other questions, and if there are none, then we'll probably call it there.
Thank you for that stellar keynote, Kyle. As you had just said, it's the time for any questions or about the field in general. Please type your question in the Q&A section and try not to ask the same question twice, and instead upvote any question you wish to see answered.
Yep. Like you said, I'm also open to any questions about game development in general. Doesn't have to be about continuous integration. If you want to ask about what it looks like in the industry right now, or what kind of games people are starting to get popular, I'm totally happy to answer any of those. Or questions about I probably should have started off by mentioning, well, I'm not sure if there's anyone here who was part of the last group, but I am from UBC Game Development. So the UBC Game Development Club, I'm actually president of that club. So any questions about what university looks like, or what it looks like developing games, part of a university club, then feel free to ask. Well, okay, so I got another question. What is my opinion on working in this field as a student? Internships are hard to get. So for years and years and years before now, they needed way more software developers. It was like a super huge needed job, and all the positions were empty, and they were trying to hire more and more. And in the same way, internships were also popping up like crazy. A lot of these companies didn't have any interns, and they were happy to have some, and they'd love to have some. Nowadays, it's picked up quite a bit. And so now there's way more people who are interested in that, and jobs and internships are a bit harder to get. If you have an awesome university program like UBC does, then you can go to co-op and get a co-op job pretty well. I'm not going to say easily, because it's not particularly easy at all. But with enough work and sending enough resumes around, it's definitely possible to get one. Not possible, but it's likely. And so that's pretty much the case. What I would kind of say is, working in the game development field, is that trying to get an internship in game development is quite difficult at the moment. A lot of students, particularly a lot of software or either software engineering or computer science students, are interested in just game development and not other fields, right? And so they have such a gigantic amount of applicants that it's kind of hard to get noticed. One thing I will say, though, the good thing about game development, and why I'm still in it despite that, is that it's easy to work on either on your own or in a team. Is that you don't particularly need to join a company in order to make a great game. You can actually make an amazing game and send it on to Steam just with you and your friends. Part of the reason why is because a lot of older companies now, they don't really have the new expertise that you'll learn like as an up-and-coming programmer now, and that kind of slows them down. But also because systems like Unity let you use a lot of external packages in order to do that kind of stuff, and so it gets quite a bit easier. But I would definitely say, like, right now the industry itself is really bad. Like, it's really tough to get in, kind of saturated. But the field itself is full of opportunities, and you can make games on your own. And in fact, even in high school, you can start making games right away. And if you have made games before, if you have a bunch of those things on your resume, etc., that kind of thing, then it's quite easy. It's quite a lot easier in order to join in on a project, because you can make yourself experienced, or you can make yourself some experience. They in a lot of other fields, like if you go into chemistry or chemical engineering or something like that, then you'll have like you can't really work on that on your own. You can't go up to your first job interview and say, yeah, hey, I've already made all these crazy chemicals, because you really can't alone. But for game development, you can. You can go up to your first interview and say, look, I've made this game and this game, and I put them on Steam, and they're pretty cool. And I've heard that they just love that. Seeing that you've already made a game, seeing that you already know what it looks like from start to finish, shows that you have amazing experience. And you can start getting experience even in high school by working on simple games and making that kind of stuff. Although everything I am saying, that's only true if you're okay with making indie games, like stuff that's pretty small and not really AAA, and not everyone is going to play. If you only want to work on the giant games that everyone's going to play, then it's a bit different. Can't really get experience for that, and you're gonna have to work hard in order to get the internship there. Someone asked, do you recommend specializing in gaming, or do you just go to school for CS and specialize later? So what I'd say is, so this is a really hard question, because one of the big misconceptions about game development is that it's all about coding. Really, coding is kind of part of it, but it actually ends up being a very, very small part. Because when you think about a game, you need a lot of different people. If your game wants to have music, you need a musician. Or, I mean, well, you just buy royalty-free, or find royalty-free music online and use that, I suppose, as well. Or if you want your own assets, like you want your own characters to be drawn and you want your own characters to move around, you're going to need art skills as well. And so when people kind of ask, if I want to make games, what do I specialize in? It's really a hard question to answer. What most people do is specialize in computer science and then go and kind of learn the other parts on their own or something like that. But realistically, it depends on what you want to do in games, right? If you just want to do coding in games, like you just want to work on only the programming, that's all you care about, then I definitely recommend, like, you have to go into CS, or not have to, but you could go into computer science or computer engineering and learn a lot of computer systems and coding that way. That would definitely work. Now, let's say instead you want to do the art for games. I wouldn't recommend going into computer science at all. I'd recommend going into art or something like that, or even, well, or even just working on art on your own, and then kind of learning it that way. And then, all of these things, like whether it's just programming or whether it's just art, they can be learned on their own outside of post-secondary and outside of school. It's possible, and in some cases even simple, to learn programming for video games without needing a degree. The same way you could learn art for games without having an art degree. But it's not. I mean, if there's one part of it you really love and you want to be really good at, it's always useful to get more education for it. So that's what I'd say. I'd say think about what you want to do for video games. If you want to do coding, then yeah, sure, I'd go and specialize in coding in post-secondary. But if you want to do other stuff, then I recommend other stuff. Some people will ask, well, Kyle, I want to do game design. I just want to design the games and make up all the mechanics and all that kind of stuff. That one ends up being a bit tougher. For every designer, you need many, many programmers and many, many more artists, right? And so it's quite hard to just get in as a designer. There are some schools, like for example, over here, the Vancouver Film School gives a game design degree. But those degrees aren't particularly that powerful, and they don't particularly teach you the most useful things. A lot of game design comes from creativity, and creativity is a hard thing to teach. But if you're only interested in game design, I'd recommend picking another aspect of game development that you like a ton. Like if you like coding or you like art, picking that, and then kind of going to school for that, and then kind of making a ton of games on your own and designing those, and then that kind of being your fun, and then later having shown that you've designed multiple games, that's kind of your bit of your experience there. That's just my opinion, though. I'm not particularly a fan of game design degrees or schools that say, here we have a class that's just video games. Usually when they do that, people who go there seem to like it, but it doesn't particularly teach you how to make unique and interesting games. It kind of teaches you what you'd need to do if you were working for a big company. Someone asks, are there any coding languages that game developers prioritize? I want to better my skills rather in learning one rather than learning all of them. Well, so that does depend on what kind of things you want to do. So there's no single answer for that because there's a lot of different game engines that use different coding languages. What I'd recommend doing, so my favorite is Unity. So the Unity game engine, you probably heard of this, it makes a lot of games. It's always been my favorite because there's a lot of packages that you can add in, and it makes it a lot easier from an individual's perspective to add a bunch of stuff. There's also Unreal Engine, and that's similar. It's got really good graphics, but not as many packages. Okay, but unfortunately, Unity uses C#, and Unreal uses C++. And despite both of them having C in their name, they're as different as night and day. The thing that I like the most, so my personal recommendation, although a lot of people would disagree with this, would be Java and C#. They're practically the same language, so maybe just learn C#. But if you go into Unity and if you get really good at object-oriented programming, that's the key, is object-oriented programming. That can save you so much work with games. Because in the end, when you have a big game, all of those entities, all the enemies, all the players, those are all game objects, right? And those are all object-oriented controlled. So if you're really good at object-oriented programming and you understand it well, it might save you a ton of time and make you really good at a lot of those coding stuff. There's a lot of tricks to object-oriented programming, too many for me to go over here, that make it a lot easier. But yeah, that's what I'd recommend. Although there's someone out there right now who's turning in his grave because they prefer Unreal Engine, and that's entirely different with C++, so it doesn't really matter. Someone asked if me or my friends in game development are all avid gamers, and if it's fun to design games as it is to play them. So here's actually a bit of a not misconception, but a bit of a thing that most people don't know. So personally, I'm a huge gamer. The only thing I do more than I guess I play more games than I make them anyway. But I love playing games, and my Steam library is gigantic, enormous even. I have so many games, it's not even funny. I love games. But a lot of people in the Game Development Club and in the industry actually don't particularly play very many games. Some people say that making games, or at least from the coding or the visual aspect, is completely different from playing them. And they're quite unrelated in that aspect. And they are kind of true. If you just went into coding and you didn't design games at all, you could definitely just do the coding, have no knowledge of games, and still do well. And a lot of people still end up doing that. To me, though, the reason why I chose game development was because I love playing games. And I think people who love playing games and are familiar with how other games work, it helps a lot with designing games. Like if you were there for my earlier workshop, the game design workshop, yeah, I took a bunch of games that I loved a lot and I've played before, and I used them to create a new idea that might actually be pretty good. And that kind of stuff, having experience with what games are fun and knowing that people are going to enjoy this kind of thing, can help a lot with game design. If you go to the game design schools, they'll tell you that's not particularly important, and you don't have to know that. And instead, they'll kind of give you a rule book that says here is what is fun, and here is what is not. And sometimes that works, and that produces a lot of really good cookie cutter kind of games out there, which is what the industry likes. But personally, to me, playing video games is pretty awesome, and because I love playing video games, is why I love designing them. But yeah, I hope that answers your question. Although it is also true, if you love playing really big multiplayer games, like if you're a big fan of Apex Legends, or you're a big fan of League of Legends, or another game that ends in legend, if you're a big fan of those mostly multiplayer big online games, then you might not find it so much fun to design games. Or, I mean, not exactly. I'm a huge fan of those too, but I'm saying if only those are the games you like, then designing games might not be too important to you, because the part that you like isn't particularly always the design of the game, and it isn't like the fact that they added this gun and that. It's more the competition, it's more the rush of playing it, and it's more the being able to play with and against other people. And in that case, if that's what you love about games, you might not find designing as fun. Now, if you play a ton of indie games, like let's say you're a big fan of Undertale, you're a big fan of the big story games, the things that have these unique and interesting mechanics, then yeah, you're gonna, I think you'll like designing games, because you're interested in the ideas and the concepts and playing something new that hasn't really been done before. That is kind of one thing that there's a gigantic gap difference between multiplayer games like Fortnite and Apex Legends and single player or sometimes multiplayer, but more story based and some often smaller games like, if you ever heard of Ori and the Blind Forest, what other popular indie games are there right now? Celeste, that was a big one. Among Us was also an indie game, but that's a bit different. But all those kind of smaller games, the thing that makes them so good is that they're unique. For the bigger games, the thing that makes them so good is that they're kind of well polished. So think about Apex Legends, right? Or which is just like Fortnite. It's got the same concept, the same idea, and the same everything as a bunch of other, well, I mean, not exactly the same, but very similar everything to other battle royale games. Well, it's so similar to them that it's always competing with them, and it's always, trying to do better and be more enjoyable than the other one and have all that stuff. And that is an entirely, completely different thing from a story game like Undertale or something like that, where the reason why you're playing it is because you haven't played a story like that before, and you haven't seen that before, right? And something new is interesting and fun. And because those are so insanely different, there's kind of like a big divide in the middle of game development. There's almost two different kinds of game development in that way. Or at least that's just my opinion on it. Some people might kind of disagree and say, no, well, the reason why indie games are small and not very many people play them is because they suck, and that's why. And really, only those big games are the best. I don't think that's the case, but yeah, some people will say there isn't a divide. There's just good games and bad games. But I disagree with that. Anyway, yeah, that's just my general idea about it. Unfortunately, most of my companions or most of my peers in the game development club, they don't play very many video games, unfortunately. Like they play a couple, but not very many. Which I always find quite unfortunate. Well, yeah, any other questions? If not, I'm just going to keep talking about video games in general. Yeah, well, if we're, like I kind of mentioned about the market too. So I mentioned that, indie games don't sell nearly as many as or make as nearly as much money as larger, multiplayer free to play those style games. And one of the kind of reasons why is because a thing that made game development or games in general super popular, because years ago games were just something that a couple nerds played, right? It wasn't something that every child did. And that's why if you talk to some people who are a bit older, not too much older, like, they recently graduated from high school, a lot of them will have never played video games before, haven't played any at all. Well, nowadays, they added a big competitive aspect to video games, and that opened it up for a lot more people. Now it's not just people who are interested in the story and doing cool stuff. Now it's become a sport almost, right? That people kind of play very competitively. And in opening that up, it added in a huge host of people who weren't particularly interested in playing a story, but they were interested in competing against other people. And so that whole market that opened up, that was all made available, or all of those people joined those big multiplayer games, right? And that's kind of why the big multiplayer games are popular and huge right now. Or at least in my opinion. But that doesn't mean that indie games aren't worth making, because still, like, they require way less work, way less upkeep. They can be simply made. For example, Undertale was made by just one guy, right? I mean, it might have taken 4 years, but that one guy sold tons and tons and tons of copies of that game, right? I mean, surely that was certainly worth it, right? Of course, not every indie game can be as popular as Undertale or Celeste, but still, at the very least, they're definitely worth to make. All right. Well, looks like we are coming up around the end of the time. I think I have another workshop in about 5 minutes. So if you got any last burning questions, feel free to send them in now. If way later you end up coming up with a question, you can feel free to either send me an email or message me on Discord. I have joined the Discord for the project, or for the conference. You can find me right here, Kyle Van Winkoop. Yep. Feel free to send me a message, ask me about stuff, ask me for help with any aspect of code game development. I'm always happy to help. I think that if there's no other questions, we'll probably call it there. I'll prepare for the next workshop. So yeah, thank you guys for having me and letting me rant on and on about games.
And thank you so much once again, Kyle, for your time and extraordinary presentation and answers. I am sure every single one of us has learned a lot of new aspects of this career. Why don't we all give another warm round of virtual applause?
Thank you so much, Kyle. And I would also like to thank everyone who has given a lot of interesting questions and paid their interest throughout the whole talk. We will now move to our last session of today's conference, which is another workshop on pixel art. We will now move to the other Zoom room, and the conference will be resumed in a few minutes.